last week I gave you this PowerPoint. It was this slide in particular that I asked you to figure out what it is and why is it. So we have brass, we have Italian salad dressing, we have sweetened iced tea, dirt and water, diamond acetate, and milk. So what are these? Remember our two types of mixtures, homogeneous, heterogeneous. With our homogeneous, then we have solution. Now it may be a solution, it may not be. Then heterogeneous, it could be a colloid or it could be a suspension. Might not be either one of those. So we're trying to figure out what all these things are and why. First, brass. Brass is a mixture of copper and zinc. If you don't know what it looks like, there it is. It's copper and zinc, and it's put together, and it is a homogeneous mixture of copper and zinc. It is not a solution. Remember, solution has to have a solvent. When you look at this mixture right here under a microscope, the copper and the zinc are going to be evenly covered throughout the mixture. All right, so Italian salad dressing. You ever seen those bottles of food or whatever, and it says on there, in little words, for best results, shake or shake vigorously or shake before using. If it says that, well, that's pretty much a guarantee that it is a heterogeneous mixture. In this case, salad dressing is made from a whole slew of stuff. It's water and vinegar and lemon juice and oil and peppers and other kinds of spices that are in it. And it separates out. You can see if it's been in your refrigerator for a long time, you can see kind of layers of stuff. And so what you want to do is you want to take it and you want to mix it up really, really well and then use it and then put it down. And every time you want to add a little bit more, you better shake it all up so you can get all of the ingredients kind of mixed together evenly. Or else you can just pour it out and whatever's on the top layer, that's what you're going to get. So it is a heterogeneous mixture, and it is a suspension. The things in there are suspended, and if they're left by themselves, like in your fridge, they will settle out, they will fall out. Sweet tea, you should know this already, because I've said this in class, I've said this on a video, but my sweet tea is a homogeneous mixture. It is a solution because it has a liquid solvent, which is water, and then it has two solutes in it. It has tea leaves and it has the sweetener, which is sugar. All right, next on here we have dirt and water. This is a cool little thing that you can do at home. Just go out and get yourself a couple of handfuls of dirt, put it in a mason jar, put some water, close the lid, shake it up real good, and then leave it and don't touch it. After a time, all of those dirt particles will start settling down in the bottom of that mason jar. That will tell you that it is a heterogeneous mixture and it is a suspension. It is a suspension because in a suspension, the particles that are in there, the solid particles, are larger than would be a colloid. All right, so next, threw this one in here, kind of throw you. It's a diamond. We can look up here, everything is matter. So diamond is pure substance. It is an element. It is carbon. Carbon in its crystalline shape. Remember, you have a hunk of coal is also just carbon. But what happens is the heat and the pressure underneath the earth will cause all of those individual atoms to form into crystalline patterns. And with enough time, with enough heat, with enough pressure, that hunk of coal will eventually turn into a diamond. acetate. Again, not one of our homogeneous or heterogeneous mixtures. It is a compound. It is a pure substance, and it is a compound. It is chemically put together. Long chain of carbon with hydrogen in there and oxygen and a few other things. And the last one we have here is milk. Now, while milk may look like it is even throughout, you're tempted to say that this is a homogeneous solution, because you can't see all the little bitty particles that are in there. However, it is a heterogeneous mixture, and it is a colloid. And the only way that you can really determine this is if you look at the substance under a microscope. You can then see all the particles are separated, and the mixture is kind of, under a microscope it looks kind of weird. You can see all the different little pieces individual, but when you zoom out and you have your glass of milk, it just looks like pure one substance. Colloids a lot of times can be a little difficult to tell whether or not it is a heterogeneous colloid mixture or a homogeneous solution. So there you go. Here's our things. We have brass, and it is a homogeneous mixture of solid, copper and zinc. We have Italian salad dressing. It is a heterogeneous mixture in a suspension. We have sweet tea, which is a homogeneous solution with liquid water as a solvent and 2 solutes. We have dirt and water, which is a heterogeneous mixture. It is a suspension. We have diamond, which is a pure substance made of carbon. We have acetate, which is a pure substance that is a compound. And then lastly, again, milk is a colloid. And it is, the particles in there are so small, it looks like it's homogeneous, but it's not. It is a heterogeneous colloid.